Hello, welcome back to our little series writing a mini version of Rust in Rust. It's an interpreted version of it as opposed to compiled, but it's still going to be type checked, and that's been some of the stuff that's most challenging to me because I've never written a type checker before, and I think we're starting to see that I have no idea what I'm doing. This time we're going to keep looking for to-dos that we've scattered around the code that are kind of doable in a reasonable amount of time without completely implementing stuff, and maybe we'll get onto something a bit bigger like getting rid of some of these ones. So the first thing that I think we need to address is the fact that last time we changed the evaluation test so that they did type checking on the syntax tree, but there's a few tests inside here that do it differently. They run the evaluator and try and find an error, and those ones we haven't yet added type checking. So let's do it now by extracting this out and saying, I guess this should be called parsed or something. Like that. What does parse unwrap do? It parses it and unwraps it. And then we should just run type check on that, which we can just call iter on parsed, I think, to pass into type check. And hang on, what does parse unwrap return? Oh, it returns an iterator. That's no good then. So we don't want to use parse unwrap like this because we don't want to turn it into an iterator. Oh no, we want to collect. Okay, let's just collect it. Maybe we're going to need this everywhere, in which case we should put it into the function, but just for a second, let's do that. This is going to be into iter on that. And we need to do some kind of expect on type check. Oh, and type check takes in code as well. Yeah, like I said, we need to just do something if it goes wrong. In fact, we should probably do this inside parse. All of this we should do inside parse unwrap, shouldn't we? Well, where else do we call eval? That's like probably real. Yeah, that's the main method. Here's the one we were just looking at. There's eval_v, which is the utility function. All right, so this is the only, currently inside here, this is the only function that like checks the error message, because this is the only, I guess this is the only type of thing that can go wrong in the evaluation phase that hasn't already gone wrong at parsing or type checking or something. Interesting. Anyway, so we can put all of this type checking stuff inside parse unwrap, and we could call this parse and type check and unwrap or something. So let's have a look inside here. We'll just do exactly what we said here. So we'll say let parsed. No, let's say let ret equal parse blah 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 dot collect, and we'll put it into it. We'll explicitly say it's a vec. And then we'll return ret dot into iter. But before we do that, we'll type check it in here. This should be ret. Shouldn't have a semicolon there. Now we can just put this code back to how it was, which is parse unwrap. Like so. Out of code, I guess. Yep. So this goes back to how it was, and now our parse unwrap function just does the same thing that our eval_v function does, which is just double check that this thing actually type checks, and I think it won't fail. So I think that's just a mini to-do that we can say we did. So it wasn't even marked as a to-do. That's how unproductive we're being right now. By the way, I did do a commit after I finished streaming the last video, so To you, Jez, and anyone else who finding it really painful how much code we'd written without doing a commit, we're now back to something sane. So let's just say type check in eval tests that look for errors. All right, so we are inevitably moving towards having to deal with this to-do, which is that we've realized we do need what we thought we needed, which is a new type of syntax tree with type information inside it. And that feels like maybe a bit of a big thing to do. So first of all, let's see whether we've got any small things we can get rid of. Well, how about this one? When we're checking assignment statements, we have said that the type that gets returned from an assignment expression, I guess we'd call it, is unit type, basically meaning that it has to be a statement. There's no useful return value from an assignment, because that's the way Rust does things. So you can't do let x equal let y equal 3 or something like that, like you can in other languages. And we have nothing testing that this is actually working, so let's write just a little unit test that checks that. Again, it's going to be one of our messy types of unit tests that has to construct a horrible syntax tree, like this one, instead of just testing nice code like we like, because we need to check that return type. I mean, I guess if we do that to do what I was talking about earlier, we might have a better way of checking this stuff, which would be quite nice. But all right, so type checking a statement returns unit. We want something quite similar to this. We want type checking an assignment returns unit. So it's going to be instead of it being a statement, it's going to be an assignment. And what is expected within an assignment is going to be all of this stuff. So it needs a symbol, which is going to be a symbol token. Let's just make sure we're following our rule of always writing stuff different from the last test so that we're checking more and more stuff. So this is going to need to be a variable with a longer name. So we haven't had many of them. They've all been called X so far, which seems a bit of an oversight. And I guess its span is going to be longer then. And it's going to have a type. All right, so we don't really care about the type here because we're checking that it returns unit, and then the expression is going to be a boxed syntax tree. So we need to put some kind of syntax tree in here. It can be the simplest one possible, which is going to be a leaf, which needs a leaf token inside it, which needs a leaf token kind. You can see again why this is so painful. And we don't want to do this type of test too often, but in this case, we need to, I guess that's 4 long. So when we have an assignment and we ask to type check it, the answer we get back should be unit. And oops, and I think this will already pass. So I guess we better check that it fails before we're happy. Let's imagine that it returns back an int instead. And that fails, so we're all good. So that was just a little to do that we knew we needed to do. Did I break it? No. All right. So let's do that, and then let's think about what we're going to do to move ourselves towards a type checking that really makes sense. So test for the type of an assignment. because I'm really convinced now that this shortcut of type checking doesn't actually do anything. It just checks what you've already done is not good enough for us, because we actually had to cheat somewhere in our type checking testing. Where was it? Yeah, here. We had to cheat and say we found an integer, and we thought it. We expected an F64, but actually that's lying to us. It always says integer. So if we're going to do this properly, we're going to need to remember the type that we figured out for 91 plus 12 and store it in our new tree thing that we're making, so that we can report later what we found here. And I think, yeah, generally the whole thing felt weird that we were just type checking and throwing away the answer. It feels like the way this should work is that this should fit the same pattern as all our other stuff. So the tokens get created by lexing, the syntax trees get created by parsing, and then the typed syntax trees get created by type checking, and then we pass the typed syntax trees into the evaluator. And I think either the evaluator is going to use some of that type information as well to do its job, or maybe just the type checking is going to do. Certainly the errors coming out of the evaluator are going to use it, but I think probably we'll end up using it anyway, maybe for some kind of inference that happens at evaluation time. Maybe. I'm really unsure about that. So basically what this is going to be is let typed syntax trees. It's plural, by the way, because each syntax tree, as the way I'm thinking about it, each syntax tree is a basically every statement or something like that in the top level. I guess every function or every struct or whatever at the top level, that will be its own syntax tree in the way I'm thinking about it. So there's going to be a thing called a type syntax tree, and type check is going to return a iterator over typed syntax trees, which means that we can get rid of this collect business here and just say parse it, give us back an iterator, which is what parse does. Doesn't it? What does parse give us back? So lex gives us back. Oh no, we're collecting all these things. Why are we doing that? It's because it gives us back an iterator over result, right? And we want a result over iterator. Yeah, when you lex the next one, you get back a result. All right, so we're going to continue following this pattern for now, and then at some point we need to do don't read everything into a vec. Just use iterators. Just use iterators, and I think there's some kind of iterator operation that we can do that will allow us to iterate through those results that are coming back one by one through the iterator. But yeah, this is a convenient way of doing it. If we collect into a result of vec, it takes a iterator of result and gives us back a result of vec. So it kind of, if any one of those things fails, it wraps the whole thing up in the result instead. Yeah, so we'll do the same thing here. We'll do .collect. No, it should be just .collect. Yeah. It's confused because the type of type check is not yet right. And again, we're going to collect it into yet result of vec of something. It's going to be typed syntax tree, which doesn't exist yet. Then we can question mark it because now it's a result. And then type syntax trees is going to get passed in. Now we can turn syntax trees into an iterator instead of taking a reference to it. And it should all work. So in order for this to happen, type check needs to return let's do the same. Let's look at what parse returns. Parse returns a parse. So we're going to do something similar to this. It's going to return a type. It's going to return a type check, I guess. Which is a it takes in syntax trees. So this is a backtrackable iterator of syntax tree, I think. I'm not sure why we're writing this twice here. That's interesting, isn't it? So yeah, parse returns a parse, and this is going to return a type check, like so. And that means that type check tree is going to. So we now need to implement iterator for parse, and then we're going to end up with some kind of parse next, like type check next function like this. All the code's going to end up in there. But yeah, when we're implementing an iterator for our type check thing, it's going to look like this. Yeah, and those functions are going to end up in the impl of type check, so we'll get there. So impl iterator for type check, where it's iterating over syntax trees. The item is going to be, it's going to be a typed syntax tree, which we haven't actually defined yet. And this is going to be type check next. And then type check tree and stuff are going to be functions that type check next calls. So we're going to need to impl type check. And we're going to need to provide a function called type check next. So I'm just copying, I'm not explaining this brilliantly because I'm just copying it from what we did before for the thing. And type check next is going to return an option of it's going to return an option of syntax tree. Do we need to explicitly say that? Probably no. It's going to should be returning an option of typed syntax tree, and this is wrong here. This should be typed syntax tree. Because parse is returning the item is a result of syntax tree. Yeah. Oh, so no, this was right. This was right. It takes in an iterator of syntax trees. That's what I is, and it returns a result of typed syntax tree every time you call it. And we could just return none from here to have some things compile. And yeah, this should have the same generics, similar to what this does. So this should be type check. And it's iterating over syntax trees. And we need a typed syntax tree, and some other stuff is not working. Yeah, so when this type check function should just return, it should just return a type check. So let's look at what the parse function does. Yeah, parse function just returns a parse, right? So we're going to do something very similar here. And this whole stuff can just go. So it's going to return a type check where the syntax tree is going to be a backtrackable iterator of trees. This is all just boilerplate to say it's now an iterator. What have we done wrong? What have we done wrong? Some kind of reference, there's a reference where it shouldn't be or something like that. It's an iterator. Oh, I see. Yeah, it should be an iterator over a syntax tree, right? Because the reason why we had a reference there was because type check wasn't actually consuming the thing that was passed in, but now it is going to consume the thing that's passed in. So someone's complaining, but I guess it might be where we call this. We're passing in a reference when we shouldn't be, maybe? No, it looks okay here. Maybe somewhere else. Won't worry about that yet. What we will worry about is that the type syntax tree doesn't exist yet. So we've got this type constraint thing. Where does syntax tree get defined? It must surely be inside parse, right? So we're going to do something similar. Yeah, right here. Nearish the bottom of... So we'll do something similar. We'll have a thing called a typed syntax tree. Nearish the bottom, but before the tests, and before the errors, I guess. But after these functions... Is it a struct or an enum? Well, the syntax tree is going to be very similar to syntax tree. So my first guess is that it is going to be an enum. We'll see. Make it public. And see, we're just doing compiler-driven development. No method type check next found for... That's because this should be a method. And we expected a result and we got back a thing. So yeah, this should be returning a result of here. I'm not sure how I missed that, but it should definitely be returning that, I reckon. Let's just double check what parser does for the parse next function. Yeah, returns a result, option of result of syntax tree. So type check next is a similar type of thing. And it is an option result, not a result of option, so that's all fine. Okay, keep following the errors and we'll get there in the end. So this, yeah, because this now doesn't work the way it used to, we can't do this. It's just, I think this should just be calling into iter. Instead of iter. And now there's no expect on it because it, yeah, right. So let's think about this a little bit more. I think we need a type check v function like we have an eval v in the other tests, and that will help us. So I think we should do a type check v on code, and then do an expect on it. How does this work in the parser? Again, let's look at our parser tests because it's going to be so similar. For things that go well, it does a parse v, and it returns like a, but that returns a syntax tree, and it actually, you don't even need the expect because that all happens inside type check V. And I guess, therefore, we should do some kind of assertion that this actually gets parsed into something useful. Yeah. So it should be assert that it's equal to something like a typed syntax tree. Well, I guess a list of typed syntax trees. Something. We'll write down what it actually should be in a minute. So this should be an assignment. And I don't know how these type syntax trees are going to work. Is it going to be exactly like a syntax tree but with a type as an additional kind of field inside it? I feel like it is, because the alternative is to have it be a syntax tree but with every item of that syntax tree is like a tuple with a type and a syntax tree or something, but then the syntax trees wouldn't actually contain each other. So I think it has to be something that looks exactly like an assignment, except it has this additional type field, which is a evaluated type of this assignment. So in that case, we know that the type of an assignment is always unit, and then it's also going to have other fields. And typecheckV doesn't exist yet, so let's write a function called typecheckV. Maybe we get rid of parse unwrap, we'll see. Takes in some code. So this is a helper function that does the type checking and gives us back like a nice, easy to consume return value, and just unwraps if something goes wrong. So it's going to look like I guess it's going to look like calling parse unwrap, and then passing the result in to type check. We're turning it into an iterator, and then it's going to need to do some kind of collect. Into a vector. Oh no, it's going to collect into a result of vector. And then it's going to do an expect. Like type checking failed. And it should be a MET result. I guess we should say in here what it is. This is a result of type syntax tree. Just to make it nice and explicit. So this is what we're going to do for every test. We're going to do do the type checking and just make sure it's all fine in that function. So we've got a few problems here. One is that obviously this doesn't actually exist. And two is that this type check function no longer is the right thing to do. So let's change all of the places where we call type check into calling type check V. And I guess they're all going to need some kind of assertion about what happens now, aren't they? And then all we've got to do is make the assertions correct, which is going to be the easy part. Maybe. So let's make this typed syntax tree assignment thing exist. And let's make it have a type, which is a type constraint. And it should definitely have other things. And I feel like we should, before we accidentally forget, let's just make it have the other things it should have. So a syntax tree looks like this. A type syntax tree is going to look really similar, which is kind of weird. But we've had this before, haven't we? Where we had to do tokens and like leaf tokens that would look really similar, but they were different. So even a leaf has a type, so now everything is going to be a struct like enum thing. If we find a better structure for this, like maybe every, because every branch of the enum is going to have a type. Maybe it would be better to have type syntax tree be a struct of type comma thing that lives inside type syntax tree. But I think for now we'll do it like this and see how it feels. And we'll find out soon enough. Inside statement, I guess the thing is going to be called statement, right? We'll bring in operator token. A type, so yeah, I think that's right. That's right. Well, maybe statement isn't the right word for this, but we'll live with it for now. So now this type syntax tree assignment needs some more stuff passed in. So does this one. And now the compiler is telling us what we need to pass in, which is nice. So first of all, hold on. I've named this differently from this. Oh no, okay. Oh dear, this is bad. There's two different types of type. That's terrible. So assignment in typed syntax tree, where is that? An assignment has an underscore type and a type underscore. That is really terrible. So first of all, let's rename type underscore type to type underscore, so that we're consistent with the other place where we name it. But now we really need to do something here. This needs to be declared type or something like that. Don't need the underscore anymore. And that's fine for here, but if we're going to call it that here, we should call it that in a syntax tree as well. So we're going to need to do a rename, and now things are getting really bad. So I'm stopping. Whoa, what did I do? So we need to stash what we're doing. I'm glad I did a commit now. And then I need to, so that means we're back to nothing's changed here. Now I need to rename this but with nothing else having been changed and make that a separate commit. Oh dear, what have I done now? I might have just done the wrong thing with that prompt that popped up in Vim, we'll see. Yep, I definitely did. Alright, let's undo all of this. Let's make sure everything is read in, I guess. Can I do that? And let's try again. So now I think I've done my refactoring without messing anything else up. I've renamed this thing from type underscore to declared underscore type. Now this can be a nice separate commit where all we do is rename that. rename the type in assignment to declared type. Better. Oh, we didn't check it works, did we? Oh, it doesn't work. Okay. Well then, let's undo that commit. We haven't pushed it yet, which is lucky. And let's find out how we managed to break things. And when I told it to rename, I was expecting it to do a better job of renaming. I guess we should change the argument in here as well. And it wasn't actually used, which is why I had an underscore at the beginning, so that's okay. What other errors are there? Yeah, this is a little odd that it didn't pick up on all of these. But it has the advantage of reminding us that we need to change like some of these argument names as well, which wouldn't have got picked up. Oh, I should have done rename there. That would have been much better. In fact, let's rename this one too. No, let's use rename for that. You can't rename it to an invalid name, like I just typoed. Alright, so there you go. I think that's all good. This should be declared type as well. Alright, so that seems to be all the errors. So is it going to pass now? Okay, better. Okay. So now hopefully we've fixed all the declared types. Let's just do a quick search for type underscore. Oh, here's one. Any more? Type underscore, and then what do we do to say end of word? Is it that? No, definitely not. Maybe it just needed to be quoted. I really don't know whether I'm typing the right thing there, so I'm just going to have to do it manually. Fine. Nothing suspicious looking. Alright, well, we're close enough. Right, so one more go, check it really works. And we can reuse the commit description that we had before. And now we can git -pop, and it might conflict a bit. No, it was fine. So we've got back to what we were working on really, which was making this new typed syntax tree where there's a type and a declared type because of the fact that we've just introduced this new type into it. That's why we did all this. So let's just make sure that we've really read in changed things and see whether, yeah, all right. So declared type is going to be some kind of to do, and type is going to be unit. So back to something more like what we wanted to go for. When we parse and type check an assignment, we get back an assignment. And it's just a bit confused, I think, because we said declared type. Oh no, we missed a comma. Right, that's what's going on there. And again here. Right. So when we make an assignment statement, it should come out as a typed syntax tree assignment. Its type should be unit, because assignments always, well, even when there's no semicolon, which is what this should have. So this, all right, this one can be a statement. This one can be an assignment. Let's have it that way. So this, we're going to have to be cleverer. This is going to need to be a type syntax tree statement. And the type of that is going to be unit. And the statement is going to be a box containing the other thing we just made. Close the thing like that. I think that's right. Yeah, okay. And statement in a typed thing shouldn't be a syntax tree. It should be a typed syntax tree. So that's helped find a problem that we had inserted into our code. So when we parse and type check an assignment, we get an assignment with a type of unit and a symbol of, in this case, X. Let's change it up, because we said we'd be changing things, didn't we? Let's call it ZZ. An expression, which is itself what is an expression? It's a box of a typed syntax tree, : leaf of type leaf token. Right, hold on. No, of type constraint int, because the expression is of type int, and the token is a leaf token. With a leaf token kind, this is getting long. Basically, it's a 3, and its span we better guess. And so 8,1 or something. What is it? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, I think. And again, this expression should be a typed syntax tree. Are there any other syntax trees? Yeah, left and right here should also be typed. Everything inside a typed syntax tree is itself typed. That's the whole point of it. All right, so this should be a symbol token, which I had to do to rename actually. And symbol token has inside it a symbol and a span. Which is we'll fix in a minute. It's going to be something. So symbol token goes from 0, 1, 2, 3, 4, and it's too wide. Now, what's your problem? Oh, just that you can't get there because there's some kind of to do. Yeah. So the declared type in this case is a symbol token. There's something is declared here, and it's a symbol token with a symbol of I32, and that is from 4, 5, 6, 7, 8 for 3, a span of 3. Yeah, so this whole thing, because we've got the span, we actually don't need these symbols in there, but then maybe they help us debug. I don't know. We'll see. Maybe they help us think a bit. Okay, so that was that. And then this one's going to look pretty similar, so maybe we'll copy some of this stuff. To say the assignment looks like this. except the symbol is an X. Let's make it an XX so the things line up, shall we? Because I'm getting tired of calculating those spans, even though I've probably got it wrong. And the leaf token, this is of kind float, and it's a token kind float 23.0, and that means it's 4 long. And there's a symbol which is an F64 symbol for the declared type. So now that looks like a reasonable, I mean the test is super long, far too long. It should definitely be broken into 2 tests. So let's just say this. It was not great style to have 2 like assertions in one test anyway, but when they take up a whole page on their own, let's make them as separate tests. Now, how many more tests are there with errors in them? Should we just comment them out for now? There's quite a few. Yeah, we're completely changing the way type check works. This is just too big a change. But we got to plow through it, I think, now. We'll see. So, can we call type check? No, we can't call type check B here. We have to call parse unwrap. But I guess when we call type check, we need to call collect into immediate result of vec of something. What is it? Typed syntax tree. We forgot to actually call collect. There we go. And this should be calling into iter, because type check now takes ownership of that parsed thing. So that was easy, right? The error message should be the same. And this one seems to be okay, because I was directly checking type check leaf, which hasn't changed yet, but probably will in a minute. Okay. And now this one is calling type check, and we're just saying it shouldn't fail, but I guess now we can at least call type check V on it. We could say that we're still going to just check it doesn't fail. So we're just going to call type check V, and we know that inside that gets checked that it doesn't fail. Is that okay? I mean, at the moment, the return value from this is actually not correct anyway, so I guess we could put a to-do in here. Check the return type. Returned type is I32. For now, it isn't. Like that. This one we need to get back to at some point. We haven't actually written any code in there. And we could call type check V in some of these other cases. So we can call type check V here. And just again, expect it not to fail. But we could also check that the return type is correct. So we'll put in another to do. Check returned type is integer. Okay, and that means we don't need some other tests, right? All right, in this one we need to actually check. Right, so we're calling type check on this thing, and we need to do the same as we did before. So we need to collect it, saying that the type we expect is a get result of type of vec of typed syntax tree. Right, and this needs evaluator. Yep, that worked. And then again, now we'll just call type check v on this. Again, I guess we should check the type of what comes back. We need to get rid of these semicolons if these are going to be correct. And in this case, the return type is going to be unit. To do, check that they returned type is. So I guess what we can do instead, rather than like asserting the entire contents of what comes back, we can just assert that the type that comes back is. Okay, and that will be less messy. So I guess these tests are getting shorter, so that's good. To do, check the returned type is. Oh no, hold on. This is an error case, so I've done that completely wrong. Oh, what a waste of time. So we should be doing type check dot collect again. Exactly the same. If I can remember what it was, we get result of vec of typed syntax tree. Hopefully this is the last one. This is the last one. This should be evaluator again. What else? What else? Okay. So how are we doing? Can we run our tests? No, because there's a load of errors. All right, first the evaluator tests need to also have some kind of similar treatment. Oh, that was main. So what is main? What's wrong with main? Ah, eval. Okay, eval needs to take in a typed syntax tree. All right, so we really are messing up everything. So everywhere that we're using syntax tree in here needs to be a typed syntax tree. We should probably just literally search and replace for syntax tree in this file. Replace it with typed syntax tree. So if I'm halfway through now, it's going to be annoying to do that. So let's cast our eye over everything and hopefully it will make things better. Oh yeah, these don't have types, so we need to provide them. What does leaf have in it? There's token. And I guess for now we can just ignore type and all these. And at some point we may actually want them. What does statement have in it? I think it was called statement, wasn't it? Statement. So in a way it's kind of nice that these are all now the same struct style thing. Alright, so all these functions should also take in type syntax tree. Where else? And here. And here. Probably loads of other places as well. Here. Yeah, and this is where this should now be called like type check unwrap. So we'll change that in a second. But yeah, we lex it, we parse it, we type check it, and the result is the result of actually doing that. All right. So yeah, we can follow the pattern we've got here of like unwrapping as we go. By doing a dot map. We don't need a collect. We just need like another dot map unwrap like that. I think. I mean, there's a lot of unwrapping. Seems a bit awkward. So something like that. So we lex it, and then we map it over, like unwrap everything, and then we parse it, and we map it over unwrap everything, and then we type check it, and we map it over unwrap everything, and it returns an iterator with everything, with all the errors kind of swallowed. Or like we just die if we. So now when we do this, we should call type check. So syntax trees is a result. So then we do an expect on the result, and we call type check, and we need to collect on these as well. Well, I guess we should do the same thing as we do above. So tokens becomes a mut result, syntax trees becomes a mut result, and we call expect on it. And then I guess it's going to be let typed syntax trees be a similar thing. We need to declare its type because we're doing a collect on it. And it won't otherwise know. It's going to be a vec of type syntax tree. And it's going to equal type check on input using syntax trees dot expect parsing error dot into iter, and then we're going to call collect again, and that's going to give us typed syntax trees, which we can then pass into, and everything looks nice and simple, similar to before, except we've done something wrong here. We need to do an expect on it first. Type checking error. Like so. And now everything's all simple, like it should be. We're not using syntax tree anymore inside the evaluator, which feels right. 249. And this should be, we are using it in the test, so we need to import it there. Right, how are we getting on? Load of warnings, but no errors. How are our tests getting on? Everything after the type check is failing because the type check doesn't actually do anything yet. It doesn't do what it promises, at least. So let's have a look at how type check is currently working. We got this type check next function, haven't we? Where is that? Type check next, yep. And that does nothing. And what it should do is call one of our functions. So I guess type check tree. On self.file contents. I mean, we could refactor this so it's a bit more sensible. And it's going to be syntax trees.next, I guess. We can question mark that to just return none if syntax trees.next gives us back none, I think. And we're returning. We should be returning an option, so it's got to be wrapped in some. And type check tree returns a type constraint, so we should actually kind of get the type. I guess type check tree shouldn't return a type constraint. It should return a type syntax tree, I think. I think that's right. So the way we're going to fix that is that all these things like type check leaf are also going to return a type syntax tree. I think, or are we going to, when we call type check leaf, we already know that it is a is it going to be like, are we going to say here typed syntax tree? Yeah, I think here we're going to say it is we already know it's a typed syntax tree of leaf, but its type is going to be whatever type we find. No, okay, let's do it inside. Yeah, let's do it inside. So here we're going to return, we're going to kind of set the type to be this thing that we were calculating before. And we're going to return a type syntax tree leaf with a type of type and a token of the token we were given. So that seems straightforward for this should be type syntax tree. For type checking leaves, it seems doable. This should be okay. Why are we passing in a reference to a leaf token here? Shouldn't we be? Yeah, no, oh yeah, this is because before we weren't taking ownership of stuff and now we are. So let's rename this to token, shall we? To make this last line look a bit nicer. So type checking a leaf seems doable. So far it still kind of makes sense. Yeah, this shouldn't take it. Should take in just a syntax tree, not a reference to a syntax tree. So now type check operation is going to return not a type constraint. Oh, this should be met result. This is just another way of writing the same thing, but it's how we've written it everywhere else. And instead of returning a type constraint, it should return a typed syntax tree. That's not how you spell me yet, though. And all this stuff is calculating a type. So this should be let type equal this thing. And if something goes wrong, we return an error. And then we return a type syntax tree. What are we in? Operation with a type of type and all these other things. No longer references. operator left and right. So it feels a bit funny, this. I'm hoping it's going to flesh out to be a bit less funny, but we're kind of copying everything from the syntax tree into the type syntax tree, which we knew we were going to do, so it kind of makes sense. But it's feeling a little awkward right now. Now, what's your complaint here? Well, type syntax tree doesn't implement display. We'll sort that out in a minute. Type constraint. Oh, left type and right type are okay, so this should be left type dot type, I guess. So the point is left type and right type have been got by going deeper into the tree. And then kind of been thrown away. It's a bit weird, isn't it? Hold on. A type syntax tree doesn't have a type property because it's an enum, but it should have a type method or something like that to be able to get that out again. But that feels a bit, to me, a bit odd. Yeah, so we should kind of be throwing away the actual results of evaluating the left and the right. But that feels odd because then left and right are now going to need to be, yeah. So what we should actually do is evaluate left and right, not throw those away. So these should be called like left typed, let's say, and right typed. They are actually typed syntax trees, and left is going to be left typed when we're actually returning stuff, because it's all about we're going through the whole tree, like evaluating the type of everything that's already in syntax tree form, and now we're just evaluating a type and packaging that up with it. So we need to get hold of the types, the typed forms of this syntax tree, so that we can create our own typed syntax tree at the end. And then here we need to say if left typed dot type equals right typed dot type, because now we're doing like the type checking of these things. We're going to have to add that type method, and then what we return for the type is left typed dot type. And if either of these are any, we're just going to ignore for now. So again, it's going to be left typed dot type. So this is just converting to our new way of doing stuff. And now in the case where things are not good, I guess we can, we're doing this so much that we should actually put it in a variable. Left type is left type dot type. Left typed dot type. The same for right. Like so. And now I'm going to go back through and put all this stuff back to how it just was a second ago. If the left type is equal to the right type, then return the left type. If either of them is equal to any, we ignore for now. That means that this is going to work. And we're returning. This should be wrapped in an OK. We're returning a type syntax tree built up from the type syntax trees that we have just found. We need to box them. I guess they got unboxed on the way in, did they? Yeah, and now we need these type, that type method, which we'll make in a minute. So let's just look at the way in. Left is a box of syntax tree. When we call type check operation, we're passing in a syntax tree, and we're passing in a box syntax tree. We're expecting a parse a parser syntax tree. It worked before because it was a reference. No, it's not. We're actually going to take ownership of it. But it's okay because we're just going to dereference that box as we pass it in. I think it's okay. Assignments and also this type thing. Let's make this type thing. It should be pretty straightforward. So we on a typed syntax tree, we need a method which just gives us back the type. And because typed syntax tree, every variant of that enum always has a type, it should be very straightforward. And it does kind of make me wonder again, should this be a struct? Well, we can figure that out later once we've gone through this absolute nightmare of a far too big refactoring. So we're going to match on self, and in every variant that we have, we're going to return the. So it returns a type constraint, or maybe a reference to a type constraint. Can type constraints be copied? They should be able to be. We should do that. Let's just say a type constraint and we'll make it copy in a second. Let's make it copy now. In order for something to copy, it has to be clone. Because I think because the actual code it uses to actually do the copying is, it calls the clone code, something like that. And then in order to implement this, we're just going to do self dot. We're just going to do type underscore every time. Like that, maybe? Yeah. So we dereference type underscore to do this. So we could have just done type underscore dot clone, but I feel like semantically this is a copyable thing. It's like it's a very plain enum. It just has no values in it. It's all just a choice between this or this or this or this. So it makes sense for it to be copied to me. Hold on, I changed my mind. I can imagine in the future the type constraint might be cleverer than that, so let's make it clone and not copy. And then the code that we were just looking at needs to call clone on it instead of dereferencing it. Which is fine. Yeah. Just in case type constraints later become more complex things and we kind of don't notice and it all gets into a nightmare. So what have we got next? Yeah, type check next needs to take a mutable reference to self because it grabs something out of syntax trees. Okay, so assignments are not yet working the new way. So first of all, it's going to take in things not by reference. And it's going to return a typed syntax tree. It's going to figure out the we'll look at that in a second. It's going to figure out the type. No, the type is always, hold on. It's going to do some checking, and then it's going to always return type constraint unit. So we're going to do, we have tested that, I'm pretty sure. We're going to return a typed syntax tree assignment. Its type is always going to be type constraint unit. Its symbol is going to be the symbol we were passed in. And is expression is going to be the expression accepted is going to have been evaluated. So type check tree takes in a syntax tree. We're accidentally passing it a reference to a syntax tree. So I think we should just be doing star expression on that to turn that box into a syntax tree. So now we've got right hand side. Let's rename this to expression. So basically we're creating a new variable called expression, which is the basis of type checking the old variable called expression, and that's what's going to get provided in our return value. And then the declared type, hold on. Oh no, we need to put it in a box. So let's go back to calling it right hand side. Yeah. Because the reason I wanted to make it have the same name is so we could have a nice, this should be, is so that this line 256 here would be nice and simple, because it would just say expression instead of expression : box new thing. Since we have to do the box new thing anyway, let's give it a different name. Right, so now what's happening? We've got a problem here that we need a reference to an option, I think. Let me call that. And then we need to combine, when we're combining types, we just need to get hold of the type of the right hand side. So right hand side type is right hand side dot type underscore. Now we can combine that here. Now we've got everything we need. Declared type is going to be declared type, right? Hold on. No. All right. So let me think about this. Couple of things going wrong. So declared type is an option of symbol token. So exactly what we got passed in. Now, and then it's confusing. We're confusing ourselves because we got inside. Yeah, we're doing something with it. So first of all, we need to do the type checking and find out what that. If there is a declared type, find out what its type is and check whether it's valid. And then we're going to just return a type syntax tree with the original thing we got passed. Once we've checked it's valid, so we're almost there. Expression has been moved, so before it's moved we need to get hold of its span. So we can do that. Like so. Now we can use it here without having already been used up. And I guess we should also get hold of the expression as a string. Oh dear, that's a bit sad, isn't it? Is there some way we can do some of this stuff first? No, because we need the type of right hand side. So the question is, can we... well, for now, let's just say, let's just do the work here to turn the expression into a string, even though we might not need it. And then I think we need some kind of to do to say there must be a better way than before we were able to do this without calculating that string expression when we didn't need it. Now, because we're passing ownership of this thing into type check tree, passing ownership of this expression in, we need to get information out about it first. Maybe we can actually pass a reference in or something else. I want some kind of to do here to say, do we really need to calculate these? Even if there is no type error. So yeah, it feels particularly egregious to calculate them, even though the happy path will not require us to use them at all, because we only get into here if there's some kind of problem. Yeah, we only get into this if there's some kind of problem. So we'll leave that for later. We're still ploughing through this far too large thing. So where have we got to? We're type checking a tree. We've got to statement. We're passing expression in to type check tree, and then we always return unit, which should be, now we should be returning type check tree, statement. For some reason, we're not calling a helper function here. We were doing it all in here, maybe because it was very short before. Now it's not so short, it doesn't feel quite so good. It should be type constraint unit. Should be boxed. Like so. Okay. So yeah, now the type check tree function is calling all these nice little functions that wrap up our syntax tree into a type syntax tree with a type and the other information it had. And it seems to be mostly okay, because the errors we're getting now are warnings and errors in our test code. So what's the problem here? It should not be a reference to a leaf token anymore. And, instead of it being type, yeah, okay, so what we could do is just say the type of it will be type constraint int. Yeah, let's do it for now, just to get our test passing, and maybe because it's the right thing to do. We'll say, keep testing the same things you were testing before. But maybe we should at least sometimes be testing the full output. So don't pass in a reference and then ask for the type. What do we think about this function being called, this method being called type underscore? We're not enjoying that, are we? Well, at this point, I'm just kind of desperate to get any kind of test passing. I feel like we might be somewhere near. Okay, so hold on. Type constraint is more private than a function that returns it. That sounds wrong. So let's make it public. And see whether we've got no other errors or warnings. Could this pass? Oh wow, our test pass. Alright, so we've done this huge messy change, but it's made us now be much righter. So what we've changed it to be is, when you call type check, you get back an iterator over typed syntax tree. But this iterator takes a iterator of syntax trees, so that it can go through each one, and each one, when it finds it, it type checks it, and then wraps its type inside the thing, giving you back a typed syntax tree. And a typed syntax tree is one of these things. Each of these things has got a type inside it. It's also got this other information, which I feel like we should somehow mix up with syntax tree. Well, maybe you can't, because these are kind of recursive types. Maybe Rust just doesn't give you a nice way of doing that. Or we could make it generic over the type of thing that lives inside it, but that, well, we could think about that. We could think about that later. Or maybe type should be separated out, so that type syntax tree is a struct with a type plus something inside it. All of that, blah, blah, blah. Point is, type syntax tree is a type and the rest of the syntax tree information all bundled together, which gives us the ability to correctly know the type of stuff when we're dealing with higher level objects, which is where we had to cheat in that error message. So maybe next video we'll fix that so that we're no longer lying about it always being integer. And it also potentially gives us type information we can use for type inference when we're evaluating, or generally when we're doing cleverer stuff with types. We're going to need to know that type, not just at that immediate moment, but further down into the tree, probably, stuff like that. I think it just felt right to do this, and it's definitely needed for that error message. So that's what we did, and we made this huge, great diff. But the main thing is that when we're type checking, we return a type syntax tree instead of just like kind of erroring if there's a problem. And I'll get this commit done off the video. Hope you enjoyed this. This was quite a marathon, wasn't it? We'll get onto stuff that's a little bit more comprehensible hopefully in the next video. See you then.